Welcome to the Jakarta EE and Microprofile session. We're going to be speaking about the highlights of Jakarta EE and Microprofile today. We appreciate you attending, and looking forward to talking about Microprofile and Jakarta EE a bit. Just a little bit about myself and Edwin. I'm an application developer, and I do that full-time. And I'm also a database administrator. I started off as an Oracle database administrator many moons ago and kind of got into Java development so that I could do more development work. And then I kind of got into authoring. I wrote a book called The Definitive Guide to Jython back in 2009 and kind of went on to Java EE and Jakarta EE after that. I'm also a Java champion. I work a lot with Apache NetBeans. And that's me.
Yeah, I'm Edwin Derks. I'm a consultant at Team Rockers IT in the Netherlands. I'm a consultant, but I have a developer background. I did a lot of projects with Jakarta EE, Java EE back in the days, and Microprofile. And now as a Java champion, I'm here to share my knowledge and experience about Jakarta EE and Microprofile, hoping to inspire you all to also pick up this technology and make beautiful projects with it. And I think George and I can say that Jakarta EE and Microprofile are kind of our thing. So, yeah, like with your books, we are speaking and writing a lot about it. And because we really believe in the technology and hope that with newer versions of Jakarta EE 10 and other versions that will come out, there will be more Jakarta in the near future. I'll give the word to you first for some demos.
And I just want to mention that if you look anywhere with the Microprofile, you'll see Edwin's name. He's a big, active community member for Microprofile and does a lot with it. So very good stuff, very knowledgeable man. So what this session's all about, it's just about giving you some demos on Jakarta EE and Microprofile. Some things you may not do every day and wouldn't have known about until you've seen it here. Other things you may know, and hopefully we'll show you a trick or two, something you can do differently with the technology. And also want to just reiterate how well these two technologies work together. These are not supposed to be opposing technologies. They are meant to work together. And hopefully we can show you a little bit more of how well they do that. And again, questions, if you have any, just feel free to ask. So first, we'll take a look at Jakarta EE, and we'll look at a few demos here, and I'll give you a couple of brief explanations of what's new in these technologies, but I'm not going to deep dive into anything that's brand new for this session. We are going to stick with application examples that we've developed. They're tried and true and tested, and we are working on revamping this for Java 1 to include Jakarta EE 10 content, so attend our session there for an update. So if you want to get started today with this presentation material, you can go and download Pyra or some other Jakarta EE 9 or Jakarta EE 9.1 compatible runtime. You should know also that Jakarta EE 10 was released just the other day, so this is a big week for Jakarta EE, and if you would like to try out Jakarta EE 10, please do so. This code should work with Jakarta EE 10. However, we didn't have time to test it out with the Pyra 6 runtime yet, so that's why we've kind of stuck with this today. We didn't want to be running with demos that weren't working. So, and then all you have to do is actually put the dependencies in your POM, your Maven POM. Very easy to do. Since Jakarta EE has just about everything baked into it, you can use the full profile and you can get off and running and everything should work well. Just a couple of quick notes about Jakarta EE. You may not know that Jakarta EE 9.1 works with Java 11, JDK 11, and JDK 17 will work with Jakarta EE 10. So if you're interested in doing that, and that's great because that gives the developers a chance to start to make use of the new features in the JDK, which are great. There's some great features. Now, if you're working with Jakarta EE 8, then you'll have to work with Java 8. So that's just something to keep in mind. And Jakarta EE9 is not backward compatible with Jakarta EE8 because of the namespace change. So that may be something that you'll have to kind of look into as well. If you take a look at our demos online, you'll see that we mixed these technologies just to show how well they work together. You'll see that we have 3 services in our example. There's a front-end service, which is running on Jakarta EE8 and Prime Faces. And then we have 2 back-end services that are running on Jakarta EE9.1. So I'm going to dive into the different specifications now. And first off is Jakarta Faces. This is specification that's been around for a long time. I can remember I started to use it back in about 2004. And reading through the spec documents, and I thought it was great. It was huge change from using servlets or JSP and writing all that Java code right inside the page. That was not good. Jakarta Faces uses tags, facelets, and so it has an expression language that it uses. And one of the newer features is the local date time conversion, so it works well with the Java date time library. Also, something that is newer is if you look down a little bit, we can create Jakarta Faces with Java now in Jakarta EE10. So that's something you can look forward to doing with Jakarta EE10. If you don't want to use the tags and the XHTML facelets, you just want to code Java, very slick how they've done it. They've implemented it well, and you can use Java code now. Something I'm going to show you today is that Jakarta Faces, some people look at it as an old technology since it's been around for so long, not very well suited for microservices, but I beg to differ. I use it every day for it, and it's very good. One of the best things about Jakarta Faces is that it has such a good depth of other libraries that you can use with it. If you'd like to use components that are already built, there are some great libraries out there, including Prime Faces and others. I'll show you Prime Faces today. And we are using view scoped controller classes to interact with remote web services for this demo.
Yeah, and there's one other thing I would like to mention. Nowadays we are accustomed to having a front end and an API in the back end that communicate with each other. But do really all applications need a separate API from a front end? In my opinion, not necessarily, because this API has to be secure and designed and everything. But if you don't want that, and you just have, for example, an internal application for your business that doesn't have to be too fancy and too disconnected from the back end, you can use server-side rendering that Jakarta Faces uses, for example. So this technology, even in microservices land, is still very applicable. And that's why Jakarta Faces is, maybe a surprise to some people. One of the most active specifications from Jakarta. So don't underestimate the value of this technology these days.
Definitely. So I'm going to show you just a little bit about just an example of how we can use this. This is what the UI should look like for our example. And I'm going to dive into it here. This is the working example on my laptop, so let's hope that everything works well. And the demo gods are with us today, and it looks like they are, so that's good. So how did I create this page? Well, this is a facelet page, and it's using Prime Faces components. They're just easy drop-in components that you don't have to really worry about JavaScript or cascading style sheets or any of that. Front-end work very much because Prime Faces takes care of it for you. Actually, there are lots of components baked right into Jakarta Faces. You don't have to use a library like Prime Faces, but there are a lot more components with Prime Faces. So this particular example here, I'm using a tab view, so you can see there's different tabs involved in this page, and we're connected to a data table. And this data table is going to show items. Well, these items are employees. And so I want to show you how I'm rendering this from a web service using Jakarta Faces. So I'm going to go to this controller. you'll see that this is just a regular CDI, context dependency injection bean. And we can tell because it's got the named annotation. And it's, of course, named Acme Employee Controller. And I've set it up to view scoped. This is a Jakarta Faces scope. So whenever the page is refreshed or you go to a new page, it refreshes that state on that page, which is very handy. And then, of course, we have the items are a list of employees. And what I'm doing here is I construct this view every time the view is refreshed. I'm going to a remote web service, and I am calling using the Jakarta REST client API and populating the employee items. And that's how they are actually getting to the view. So that was one thing I would like to show you. Next thing is just one of the newer features with JSF is that it uses conversion, and we're able to convert with the local date time now, as well as local date and whatever other Java time API that you would like to use, the different conversions you'd like to use. So that's about all I wanted to show you about the JSF at this point. Are there any questions on JSF? Well, Jakarta Faces. Sorry, I still call it JSF sometimes. I'm an old schooler. Okay. Next, I wanted to talk about Jakarta CDI and Enterprise Beans. Latest additions, these are additions in Jakarta EE 10, which I won't be showing you much of today, but there are some great features for those of you who are familiar with CDI. We've now got the CDI full and CDI light profile. What does that do? Well, it enables you to use CDI light for microservices and smaller runtime in your applications. Now, if you're familiar with CDI, you'll know that there's a beans XML file that you use for configuring your beans. Don't worry, you don't have to go in there and write a bunch of XML. It's just used for 1 or 2 configurations if you'd like. And now if you have an empty beans XML, that marks everything as an implicit bean. So you don't have to actually mark, so only those beans that are marked with named will now show up as valid CDI beans. If you're using prior to Jakarta EE10, if you have an empty beans XML, all beans in the application will be CDI enabled. We also have a new Jakarta Enterprise Lang Model API, and the platform module system, module info class files have been added to the artifacts. So for this presentation, I'd like to show you quickly how CDI and Enterprise Beans work asynchronously. Something that I should note here is that there is a new asynchronous annotation in CDI with Jakarta EE10, which is pretty much going to take care of as a replacement for the EJB async functionality. One of the things we're trying to do with Jakarta EE10 is getting kind of away from Enterprise Beans and more into CDI, make it lighter weight. Makes sense to do that. For this presentation, just to show you how to mark a bean or an event as asynchronous, you can inject an event and optionally annotate it with a qualifier, which we'll do here in this presentation. You can fire the event calling upon fire async method. So you can see here in the code that this event is just a POJO employee event. It's going to have a first and last name. And I'm injecting this into the controller method. And I qualify it with new hire. And so this is just enables me to fire multiple employee events if I want to. And I could have a new hire, I can have an old hire, I can have a terminated, fired, whatever you'd like to call it. Different qualifiers. And these would all call upon different events then. So let me go ahead and show you how this works. So one of the things where this is added to is when I'm adding an employee to this example. So I'll just do test 2, age of 20, and the start date is today. Create the employee, and it successfully created the employee. And something I can see is that you may not be able to see this very well, but it's putting some output at the command prompt, And the one thing it's doing is sending a notification to a manager. Well, the way that that's working is from this async event in the CDI bean that's being fired. So if I go back to this view, I can see that the button I'm using here is tied to a backend method. All of these fields, first name, last name, they're all populating a bean in the background. And then if I look at the create method, what is this doing? It is creating a Jakarta REST form, populating it with the contents of that bean, and then it's going to invoke a post, and it's going to submit that to the database and actually insert it into the database. And then if it's successful, it's going to populate this new employee event, and employee event is just a POJO, as I had mentioned before. Just takes a first name and a last name. So we're going to call that the payload. And then I'm going to call this fire async method and pass the payload. And it's going to then go ahead and fire that employee event. Now let me look in this code here. And I can see that this is the qualifier that I want to use as new hire, but you can make any other qualifiers just the same way, just call it something different. So kind of a qualifier is just kind of a name, a way of labeling and calling out a specific functionality. And the new hire event handler is using this observes async, and I'm passing in the qualifier and I'm passing in this employee event. And it's sending the notification, which it's actually not doing, it's just outputting to the system line. But you can also see that I've got this interface that I'm using, and I could make multiple different employee events that same way, implementing that interface.
Yeah.
And one other thing I should show you here is that I'm doing the injection up here of the employee event. So that's all you really have to do, and it will hook everything up, and you'll be able to fire asynchronous events.
Can I
Sure.
add something? So this is nice and all, a little bit of code for firing and observing events. But there is a very popular design pattern where this really is applicable, and that is command query request segregation, or in other words, CQRS. With this, you can easily fire events from the beans in your domain to other handlers that, for example, build models based on the data from that event. So with a little bit of code, you can already apply CQRS in your code, which for some developers might seem or feel like a big thing inside your domain or in your application, but it's actually pretty simple. You also have with the synchronous and asynchronous control of your transactions, so you can really shape it to any way you like, and still only use Jakarta EE technology without anything else. You don't need not additional framework like Exxon for Spring Framework.
Yep. Thank you. And so I've already showed this in the code, so I'm going to go forward and we'll go into our next. The next tech here is the JSON binding. What this enables you to do is create Java objects from JSON or vice versa. So basically it allows you to easily map primitive types, serialize collections and maps. Some of the latest additions that there are deserialization of the null to a new null value. There's now a JSON-B type deserializer and JSON-B type adapter, which is supported as a parameter type annotation. We've got now support for the handling of polymorphic types and deprecation of JSON property.nillable. So let me show you quickly how to create a JSON file from a list of objects. It's really easy to do, barely any code at all. So I've got this list of employee items, and what you would do is you would take this JSON-B builder and call create upon it, and that would create a JSON-B object. You can then just take JSON-B and to JSON, pass the items, and that will give you a string as a result, okay? And here is that in action. I click this button, it's hooked up to that same code I just showed you on screen, and this is now just displaying that JSON that was created. We can also go backwards and do the opposite direction and create Java objects. And we can also map directly to a POJO or any other type of class that you would like to do by using this JSONB builder, call upon the create method to get JSONB object again. And then this time we would say from JSON, and I would pass all the JSON that I wanted to, and I would also then, as a second parameter, pass the class that I would like to map this into, and then it will go ahead and it will give me that employee object. And so I could take this here, which is just a JSON record, right? And I can put it here, and I can say new hire 2, and it will. And what's that done is it's created this Java object. You just have to trust me, and then you can see that that object is then printing back to the front end. If I click this button here, what it's going to do is it's going to take all the employees and write them to a JSON file. And so let me show you the code behind that. Since I've got this running in containers, which Edwin will talk to you about later, I'm not going to dig and find this JSON file somewhere but that it creates, but I'll show you how it's done. So I would take this, I would create a JSON array of objects by taking a copy of all the items which we know are employee items, and then I just create this JSON array builder, and then I will traverse through these different objects here, these different employee objects, and I'll call upon the builder.add, and I can add each of the different JSON specific names that I would like to call each of these, and then pass in the values. And then when you do that, create this array, and we'll pass that array back, and then I can write that out using the JSON writer. Write that array of JSON objects to this file writer, this employees JSON. And then what that will do is, of course, put a file on your system with all the JSON contents. Very easy to do. Another API that's similarly named is JSON processing. This one allows you to parse, transform, query JSON in a very standardized fashion. There's a JSON object builder, that is used to build the JSON object. Call upon create object builder to create different JSON objects, and you can call upon a create array builder to create arrays, as I kind of have shown you already. There's some new features in this as well for Jakarta E10. There's some new APIs. There's a standard property for handling duplicate keys, clarified behavior for JSON object builder build and close, JSON generator close, and there's a number of additional small changes. So one of the things that was very new with Jakarta E8 was JSON patch and JSON pointer. What this enables you to do is take a specific element in a JSON document, point to it, and either grab that value or patch it by replacing that value with something else. So you can do this with, it works with objects or arrays and with a number of different data types. And so to quickly show you how I've done that, use this thing called a JSON pointer form. And if I show you the demo here, I'm going to point to the first element, and I'm going to replace it with test. And you can see it's writing out all the JSON, and now test is in there as the first element. And if I wanted to get to the actual first, I'd be pointing to 0. But then I'm replacing that with something new. So really what I would want to do here, in this case, is pass an entire JSON string to the pointer so that I could replace that entire JSON string if I wanted to. And the way that it works is taking this JSON array, and it's using this new JSON, or the newer JSON pointer object, and I get that by calling create pointer, and I pass some text the text that I'm passing in is the 1 or the 0, and that will create the pointer. And then I can say that I want to replace in this array, and what do I want to replace it with? Well, I'm going to replace it with the replacement string that I've typed in, which was test. If I didn't type anything, it would be JSON master, and then it would set that string. Quick and easy to do. Jakarta REST web services. This is one of my favorite APIs, very easy to use, very powerful. Some of the latest additions, there's a Java SE Bootstrap API. There's now support for multi-part media types, so you can do pictures and different media types in RESTful web services now, which is great. There's better alignment with JSON-B, automatic loading of provider extensions, and deprecation of the context annotation. So something that I've used quite a bit in this example, in these examples, Edwin and I have used the JAX RS client is what it used to be called. Now it's the Jakarta REST client, so I should update the slide. But the client API allows you to easily get from a RESTful endpoint data, and then you can display it, store it, use it, do whatever you'd like with it. And that's how we're loading our JSF pages. In this example, we are calling upon a RESTful web service somewhere, and we're using the client to get that data and then load it into local objects for use in Jakarta Faces. Another newer feature is server-sent events, which is a one-way communication channel, and it allows you to stream and blast messages to listeners. You can do multiple messages, and there's a retry, so you can constantly continue to retry if there's a failure. And the SSE event sync is used to actually send the stream of messages. SSE event is just a base event class. There's an outbound SSE event which packages an event. Let me move forward. And this would be that happening in action. It's what we would do in our example is we would push that button and it would go ahead and send out lots of messages to the people who were listening, and it would then, in this example, just display on the screen. Another specification is Jakarta security. This is providing standard security for years. Java EE didn't have lots of great libraries for this, and now this is baked right into Jakarta EE. Standard security is provided, ability to apply across multiple identity stores. You could use a database, LDAP, or embedded. Now with Jakarta EE 10, you can use OpenID for creating your authentication, which is a different specification that's kind of related. Annotations can be used for ease of development, so you don't have to wade around in XML. It can just be annotation-based. Remember, as a caller, using a cookie or identity store. It's easy group-to-role mapping, standard expression language accessor, so it's easy to use from Jakarta Faces. Simplified HTTP authentication mechanism interface. And as I had mentioned, that we've got the latest edition, including the OpenID Connect API, which enables you to work with different providers like Google, Facebook, or some other authentication provider and use that instead of creating one on your own from scratch. Jakarta Bean validation. This is one of the easiest specifications to use because it's all annotation based. If I want to make sure that a particular field in a bean is not null, I just put an annotation not null. What are some new features here? There's support for more flexible cascaded validation constraint types, support for Java util optional, support for past and future for dates. So if I wanted to make sure a date was populated with only a date from the past or the future, then I could just put that annotation on that field. And there's a list of a couple of other annotations. I'm not going to name off all of them. This has also seen some updates in Jakarta EE 10 as well. There are some new features in this as Jakarta WebSocket is actually a very fun one to use. This allows full duplex communication between peers. And you can create a WebSocket endpoint by just annotating a class with server endpoint. And then you can create a message receiver method and annotate just a method with onMessage, and it will automatically start to receive those messages. And this supports different functionality like onOpen or onAir, so it can call upon different methods on open of this message or on air. If an error occurs, it can write to another database or a log file or something. And I've got an example to show you on this as well. I don't know how many of you are JavaScript fans, but this one uses some JavaScript. I'm not the biggest JavaScript fan, but I did dabble in it a little bit here. Actually, this uses the WebSocket JavaScript object to go ahead and call upon an endpoint that was created, chat endpoint, and it takes some data from this from the chat window, passes it to the backend WebSocket, and it's easy to have communication back and forth that way. And if I show you the chat endpoint, that's the main thing I want to show you. Right here, you can see this server endpoint is what does it. This signifies that this class is going to be an endpoint, and then I can provide the path of the endpoint, and I can provide optional parameters. And as I had mentioned, there's an onOpen method, so when this gets opened, when the session starts, it passes the username and creates a message, and it will tell you welcome and the username. And then every time it receives a message, it's going to broadcast that message to anybody who's listening. On close, on air, different things can happen. The broadcast, what I'm doing is taking a list of everybody who's in the channel listening, and I'm going through each session and broadcasting that message. That's in 10 lines of code, pretty easy to do. So if I go to chat, I'll say my name is Duke. I'm going to connect, send the message, and let me open up another browser here. And I'm going to say, I'm Jconf. Great show. And now you can see these guys are chatting. That's WebSocket's full duplex communication back forth. And that's about all I've got to speak about with Jakarta EE today. And I'm going to pass it over to Edwin to speak to you about Microprofile and how we use these two together.
Yeah, thank you, Josh.
Thank you.
Well, Microprofile. Before we dive into Microprofile itself, I would like to say Jakarta EE, as you have just shown, from a historical perspective, was not fit for clouds. So if you had a big Jakarta EE monolith application and you put it in a Docker container or Kubernetes, it probably wouldn't know how to handle that. So with the kind of still development Jakarta or Java EE went under Oracle's governance, the Microprofile was invented. And Microprofile was based on the same ideals and principles as Jakarta EE, namely specifications that provide functionality for you, but with a project that would release faster and more often, and would release the cloud-native functionality that you would have in a Jakarta EE application. So nowadays, Microprofile and Jakarta EE can be found together, collaborating in for example, an application server to make every Jakarta EE application that you would have fit for cloud, because Microprofile provides the specifications to do so.
Did you want to switch to your laptop?
Yeah, I totally forgot, but
that's up to you.
Yeah, let's do that.
Okay. Just a brief intermission here.
Should be, yes. So like with Jakarta EE, you only need one annotation in your Maven POM to get started with Microprofile. So for a certain version of Microprofile, you have this one dependency and you have the whole toolset of Microprofile available for you as a developer to start developing with and do what you need to do. And one of the most important and prominent specifications in Microprofile, in my opinion, is the health check. Out of the box, Microprofile in application servers that implements health check provides health checks for your Kubernetes because it follows the Kubernetes standards to make your app run in Kubernetes in Docker containers. Because it exposes the default endpoints that you would have for an app to determine if it's live, so when it's running healthy regarding CPU and memory, but also when it's ready to receive traffic. It's at two different stages in Kubernetes. And with the startup probe, you can kind of disable the checks for the live readiness until your maybe what slower, bigger application has started up and is ready to receive traffic. But the most important and beautiful part of this all is that not every app is the same, because one app can have different requirements for being determined healthy than another. And that's where the programmatic approach of the probes come in. So if you look at the code of such a probe, as I am showing here, for demonstration purposes, I have a AGB, a stateless bean from Jakarta E, complemented with a readiness probe for Microprofile that actually represents this health check endpoint. So I need to implement the health check interface to make sure the runtime recognizes it as such. And here I can do whatever I need and would like to determine what makes my application ready. When is it ready to receive traffic? Again, for demonstration purposes, because this might not be the best thing to do in production, I'm just looking up the database and see how many entities are in there. And I'm adding this amount to the JSON body that's being generated by the health check endpoint's output. And that can be used by Kubernetes or whatever tool to determine, if this endpoint is responding with a proper response, then the application is going to be ready. Which means that until really the database can be connected, no traffic should be routed to this application because it's not ready. So that's a thing a lot of developers have to deal with, that you can easily solve this way. Die kant in. So if you call the health check endpoint from your app, after you have started it, you can see the output here. If you have 6 numbers of employees that's being returned by the health check endpoint that has been looked up in the database. Another very important specification is the config. For people that know Spring Framework, this feature has been in Spring Framework for several years, but until 2017 it was not available in Jakarta EE yet. And as of today, it is also not. But the first specification that was developed for Microprofile was the config specification, because there was the most demand for having property injection in Jakarta EE and Microprofile applications. So with this addition, for a runtime that supports both Jakarta EE and Microprofile, you could actually start injecting properties like you could with the Spring Framework. Now, and the beauty of this is that it also is now applicable for modern cloud environments, because you need to inject properties in the environment all the time, especially with Kubernetes. So if you look at the code to make this config work, you can create a class. And in this class, I'm using as default application scope bean. Nothing special, it's just a CDI bean. But here I can use the inject Again, a CDI mechanism with the config property for microprofile config, and look up a property with service.host.name. I can even give the default value if I would like. And so I'm doing also for other properties. So now, when the application is running, microprofile config will look in a certain order, where can I find this property in my configuration files? And one of the configuration files it looks is inside the app in the property file. Can I find the value here? Then I will use that value. But in cloud environments where your environment differs from acceptance to production, you probably won't have the same value for every environment, so you need to change that. And that's where Docker comes in again. For example, with Docker Compose locally, you can add the same properties to the environment, and Kubernetes will then handle the injection of the delivery of the property for the property injection. So this way your app can transfer from local environment to production without having to change and having your properties injected in every environment where necessary.
Yeah, and that's how we were using as well config to inject in the server name and the service name for those RESTful web services that we are invoking in order to populate the fields or to write the employee fields.
Thank you. But there's more to inject. Josh has already told about the JAX-RS or Jakarta REST client, but that's not all. Microprofile has its own REST client. And there was a demand for not having a declarative HTTP communication mechanism in Jakarta, but also a declarative one. And Microprofile provides the latter, which means that you can use CDI and interfaces to define your HTTP request. So like Josh said, we have two services and they communicate with each other. One service provides the employees and the other one calls them and displays them in the front end. And this interface is going to do the same. Now, what I'm doing here is using partly JAX-RS, namely I have a part of my path here, and this is the suffix of the path to the service that provides the employees. Now, we are saying we are using JSON, and the class is tied to the bean that is injecting it. And this is important for the REST client. This interface is supposed to be a REST client, so should be treated as such by the runtime. Well, here we are defining we want to fire a GET request. We produce XML or JSON, and we are calling it find all in our code. So how are you then using this interface? The code that Josh already has made is this JAX-RS client builder. It calls the other service, and I'm now going to comment it out. We see that the path for that service was being partially built up by the config, with the config properties. And I'm also going to comment it out. So how are we now going to use the interface for retrieving these employees? Well, I can inject and declare here the REST client. So this is literally the interface that I have just shown you. And I'm going to use it here to populate the items list, just like the old JAX-RS client did. So this is the same result as with the programmatic interface. There's only one thing missing, and that's the actual URL to call, because we only had the suffix for the path. And that's again where the environment comes in, because the URL that you are calling is different for every environment. So we are using the Compose or Kubernetes for delivering this URL. So I have to find it here. It's part of the property. Oh. So we are calling HTTP employee service 8080 employee service REST with the suffix acme employee service from the path that we have declared in the code. And this can be found by Microprofile REST client because we are defining the interface location here. And then this piece of MP REST URL, this is part of the specification to be recognized by the runtime. And now this URL is being used in the calls to the other service, with only having declared the interface and the configuration here. And there's another one I want to show you. That's fault tolerance. Microservices communicating with each other are prone to have problems communicating because of infrastructural issues. Data that goes over the line is not guaranteed to receive the other end or get back. So you have to build in some kind of resilience with Microprofile fault tolerance, for example. And it's very easy to just start with at least 3 annotation for that. And one is the retry. If you have a service calling another and you are like, okay, this call can fail, but then just try again without having the user getting an error, pushing a button again, stuff like that, you can improve the user interface by retrying whenever you feel this is a good idea at this location. You can also input how many retries you want, 1, 10, 100, whatever. And then accompanied with the timeout annotation, you can determine how long a service should wait for the call to return. If you have a service calling another and you expect the call to be back in like 20 milliseconds, and the default implementation says, oh, I'm going to wait 20 seconds for that, you can override that by using the timeout, so that you don't wait longer than you are wanting to wait. So with this, you can retry in timeout, and then eventually, if you want, fall back to a default mechanism that says, okay, maybe I can resolve the issue, but otherwise, if this all fails, the user gets an error. But without having this situation that cannot really be solved, in the meantime, you have the situation that you can solve with just retrying by just adding a few annotations in your application that can drastically improve your user experience.
About 5 minutes.
Okay. And there are the 2 last annotations I would like to present, the circuit breaker and the bulkhead. These are kind of the same as I just showed you, but you need to know a little more about the environment, because the circuit breaker and the bulkhead are limiting downstream data to a service that might otherwise be over requested. So it's a good idea to then limit the downstream communication. But if you are not limiting enough, then your downstream service may fall over anyway. And if you're limiting too much, then your service might not be getting enough requests. So these annotations are a little bit tricky, and you need to really know how and when to use them, but know that they are already there. So if you are using microservices with Jakarta E, you can use these annotations to get started and get up and running very fast. And if you have a Jakarta EE application that needs to move to the cloud, you only need this to get it there. So this Microprofile is in that regard is a genius addition to the whole platform. And there's one more thing I want to talk about, is the infrastructure. The whole thing, Jakarta EE Microprofile, for some reason fits ridiculously good with cloud native principles. The vision behind this platform is to use code where it belongs. The APIs from the specifications provide you with the means to, as a developer, my code needs to do this. And that's being compiled into what we call a thin var. It contains only your code, you can deploy that, and it will run on an application server. But if you are a developer that needs a database connector or a transformer, any other library that you need in your application, for example, with Spring Framework is being put in the same application, but in Jakarta you don't necessarily have to. You can put it in your infrastructure. Because according to me, my code is what I need my application to do, and how it does that, I don't care. It's part of the infrastructure. So there's this very, very thin layer of application code, and everything beyond that, your libraries, your application server, Docker, Kubernetes, your cloud infrastructure, everything is infrastructure for running your code. So if you are using Docker and Jakarta, you can very easy include your dependencies in your application server by baking them onto the Docker image. Your application server, when it starts, will find the dependencies there, load it on the class path, and then your application will run. And then you only have to make sure your app is also baked onto the Docker image, but just the thin bar with only your code. Why is this handy? Well, this prevents a lot of new problems we have regarding dependency confusions, repeatability of your builds, all these new requirements that we have on delivering software nowadays can really easily be tackled by just using the principles of Jakarta EE and Microprofile, by just having your code separated from how it runs. And that's very important, very beautiful vision, according to me. And hopefully, also George, well. Yes.
And that same concept works with Podman. If you're more familiar with Podman, same type of thing as Docker, but Red Hat.
So what's next? George already mentioned the release of Jakarta E10 last week. Microprofile 6 is on the rise and will be released later this year. And then we have a kind of a new era for the whole platform. Because Jakarta E made a big freeze. I don't think it's to the day, but 5 years have been passed since we have seen new functionality now in Jakarta E10 compared to Java E8 when it was last released in September 2017. But in the meantime, Jakarta E has proven itself to be still valuable because we see increased market share despite having no new features in the specifications. So with the release of Jakarta E10, this evolution is moving again. We have new updated specifications with a programming model that is more accurate to the day and what we expect for developers at this moment, as well as Microprofile 6. So I hope with this we go into a new kind of era, like I said, of Jakarta E technologies that are really beneficial for developers and should be used more and more. Do you have anything to add to this?
Well, I think that's the main part of the talk. I would recommend going and downloading Jakarta E and Microprofile and getting started today. If you're interested in contributing.
Yeah, you can find the URLs here. And also, if you want to look up more information about Jakarta E and Microprofile, they are easy to find on the net, so take a look.
And check back in about a month because we're going to update these demos to work with Jakarta E10 as well. Ah, yes.
Yeah. There will be a book assigning session at Java 1 this year by Emily. So if you happen to be at Java 1 in Las Vegas in October, then sure, check out the session.
Today too, right? Today.
Today too, say. Oh.
Today at 3:15 downstairs.
Oh, my mistake, sorry.
That's okay.
Yeah.
Yeah, go downstairs and get Jakarta E swag.
Yeah, and birthday cake. Yeah, go to IBM booth at 3:15. There's a lot of goodies. Jakarta E goodies, IBM goodies, and book, Microprofile, and also the cake. Birthday cake, a lot. Bring a big pocket.
Thank you all for coming.
Thank you. Appreciate it.